Alright, this is lesson 5.1. This is our lesson on word problems. So in lesson 5.0, we focused on how to solve a system of equations by typing them into Desmos. Basically, we look to see where they intersect, and then we copy down that coordinate. If they're parallel lines and don't cross, we put no solution. And if it's just one single line, we put infinite solutions. Now, when we're doing word problems, we tend not to get those two special cases. We tend to get a more definite answer. So as we're doing these today on Desmos, we should actually see a physical answer for this question. So the sum of two numbers is 39. The difference of two numbers is 11. What are the two numbers? So this goes back all the way to Unit 1, actually, in terms of writing verbal expressions and algebraic expressions. So I recognize the word sum means I'm going to add two numbers, but I don't know what the two numbers are. So as they're probably different, I give them different variables. So I'm going to go with x and y for this question. Remember, the is part of the question means that it's equal to. And as I write the second equation, difference, I remember that means subtract. So two numbers, that's going to be my x and y again. And I can say that it equals 11. Now, once we've got those two numbers, you can actually use Desmos. I've actually typed them in already just so you can see what they are. I zoomed around so I could see where they cross, and then I can see what my two answers are. So 25 and 14. Now, what we didn't do last lesson is if you want to check your answer to see if it works, obviously you can plug these back into here. So 25 add 14 is 39. Yep, the two numbers add up to 39. And 25 minus 14 equals 11. And once again, you can see that's true as well. And for a system of equations, it has to work for both equations, not just one. So for example, the sum of two numbers being 39, it could just have been 38 and 1. However, it has to apply to this rule as well, and clearly 38 take away 1 is not 11. So that's what a system of equations is. It's a set of numbers that will work for both equations at the same time. All right, let's move on to question 2. So they often like to ask questions about food in particular, and often fruit I've seen as well. So I've got a question here. 5 apples and 2 pears cost $3. 3 apples and 4 pears cost $3.20, and I have to find out how much they cost. Now for this question, I don't know how much an apple costs, but I don't really want to use X this time. As I'm talking about apples, I really want to use the letter A. And same for pears. I'm going to talk about P being the price of one pear. So as I write my question out, notice how close this word and is to the word add. And that's one of our clues for this question as well. So I want 5 apples, add 2 pears. Costing means equals. So this is literally 5A add 2P equals $3. There's my first equation. And I started to type this into Desmos as well. And 3A and is add, so 3A plus 4P equals $3.20. Now, what you'll notice here, though, is I type this into Desmos, I've got this little warning sign. So that means I've done something wrong here. And the reason something went wrong is here, when we're graphing equations, as you'll know from the previous units, we use X and Y. So if I use X and Y, it'll draw this picture perfectly. If I type it in with any other letters besides that, it will not. So what I need to do is I actually need to change the question. I can't use any letters besides X and Y. So instead of putting A and P, just put X and Y. Notice the first letter is going to correspond to the first word. So X is going to be apples for this question. You can type it in and you get 0.4 and 0.5. Now you've got to be careful for this one because it's very tempting. This was originally in dollars here. So you've got to be very careful here that you don't pick the answer as 4 cents for this one and 5 cents for this one. Now, when you see a price, normally you see two numbers after the decimal place. So if you only see 0.4, what it actually means then is 0.40. So actually the price of an apple is not 4 cents, it's actually 40 cents. And similarly, the pear would be 0.5, which is not 5 cents, it would be 50 cents. And if you wanted to, you could try it. If you buy 5 apples at 40 cents and you buy 2 pears at 50 cents, would that give you $3? Making sure you also check, though, is 3 times 40 cents add 4 times 50 cents also equal to $3.20? And the answer is that yes, it is. And on this question, I had to kind of zoom in quite a lot here because all the numbers are fairly small. They're all between 0 and 1 because we're buying something that's less than $1. So you might have to zoom in, zoom out on these questions depending on what you're doing. If I was buying cars, perhaps, then this could be thousands of dollars, and I'd really have to zoom out on that x-axis. Now, this is a slightly different question because it actually tells us how much the items cost this time. On that previous question, we had to work out how much an apple cost, but we knew how many apples we had. On this one, it's the reverse one. We know how much an item costs, but we don't know how many of the item that we have. So 125 people attend a basketball game. They take $320 in entrance fees, and then we've got these numbers here. Now also, with all these questions, you want to focus on these numbers and make sure we know exactly what they are and link them up. Like I can see I've got three numbers here that have dollars together, so I know I'm going to want to use those all in the same equation in a second. Now, the question says how many students are at the game. I can't just work out one at a time. I'm going to work both of them out. I have to work out how many adults there were and how many students there were at the same time. So I'm going to use the variables a and s for this question. That seems to make sense. And the first equation is to do with this first number. 125 people attend a basketball game. So the number of adults, that's my a, plus the number of students, that's my s, equals 125. My second statement is all to do with the numbers that we see here with the dollar signs next to them. So my adults are $4. So A4, or using commutative rule, 4A. Once again, we see this word and, which we recognize as add. Student tickets, $2. S2, 2S. What does it equal? Well, obviously the total money that you take. If you add all the money from the adults and the students together, you get the total money, which is $320. Much like the last question, you can't type this straight into Desmos. If you use A and S, then it'll give you that error. So make sure you use X and Y instead. And this time, our two numbers are 35 and 90. We've got to make sure we know which is which. So our first variable was adults. So X was A and Y was S. So as we're looking for students, we're looking for the second number. So the number for this question would be 90 students, 35 adults. We only want students this time, so 90. So you might not get this as a multiple choice question. It's very possible you could just get this as an open-ended question where you'd have to type in the numbers. Wouldn't be good for guessing because it could be any number between 0 and 125. So kind of important one to make sure you understand how to do that one. Our last question, a very common question we've been having recently, is to do with amounts of money. So a bag of nickels and dimes contains 25 coins and it is worth $2.10. How many nickels were there in the bag? Now, the reason we recognize this as a system of equations is there's two things that we don't know here. How many nickels? How many dimes? Notice there's also two numbers that go with this as well. The 25 and the $2.10. Now, technically, this is just a very special case of this question here that we just did. The only difference is it told us an adult ticket cost $4. On this question, it just tells you that it's a nickel, but it doesn't tell you what a nickel's worth. So they're assuming, of course, that you know that a nickel is 5 cents and that you know a dime is 10 cents. But the setup is going to be the same. So 25 is my number of coins. Obviously, I'm going to use N and D for this question rather than X and Y because I want nickels and dimes. So my first one is just the number of nickels plus the number of dimes equals the number of coins. For the second one, we have to be a little careful for this one. If we know that a nickel is 5 cents, and we put 5, and we put a dime is 10 cents, that's okay, but what we can't say is it's equal to $2.10. And the reason we can't do that is I used cents here, I used cents here, so I would have to do the same thing on this last one. So $2 is obviously 200 pennies, add on 10 more pennies, and that will give you 210. That's how we have to write our second equation. So we have to be a little careful when we do questions like this. Clearly, if we were talking about quarters, I could put 25Q. If I was talking about pennies, I could put 1p, because a penny is worth 1 cent. If I had half dollars, I could put 50H, H for half dollar, and so on. So which coins are you going to be asked? That's difficult to know. You might even be asked dollar bills or $5 bills. You might have to use F for $5 bills or T for $10 bills or something like that, depending on what the question is. Then I can type this in. Once again, I'm just looking for where they intersect. 8 and 17. So once again, let's just make sure we have this the right way round. Nickels was the first letter on this one, and I'm looking for nickels. So I'm looking for the first number, which is 8. Now, one other way you can actually do this question is, as this $2.10 was in dollars, you can actually put the price of a nickel in dollars as well. So they might ask you to recognize which is the correct equation. So if you saw 5 cents at a supermarket, you would actually see it probably as $0.05 with an N. And then for the nickels, you could see the same thing. Right? You could see if you saw something that was 10 cents, the price would actually say $0.10 with a D next to it. So just make sure you're aware of both equations. You can certainly use when you have to answer the question yourself, whichever one you prefer, but you might be actually asked to pick out which is the correct equation, so you'd have to make sure that you're looking at, are they all in cents or are they all in dollars? I think that's pretty much it. I did have a couple of questions. I had one from 2010, very similar to the question I had earlier, just to show you these things kind of match up. Youth tickets and adult tickets. This time it's for a school carnival, not a basketball match, but you could certainly practice on that question. And from 2008, Andrea has 37 coins, all nickels and dimes, $3.10. Once again, very similar to the question we just did on example 4, just with slightly different numbers, so you could certainly practice those ones. Go try the exercise. Certainly use Desmos for this question. You don't really want to be doing these questions by hand, particularly for the SOL when you have that Desmos calculator. Use that, and that concludes this video for solving systems of equations.